Dear boys, good morning. I'm your teacher Jana Akhtar is with you in your online class. Today is my fifth lecture with you, and on my previous lecture, I was just continuing review classes. We had a discussion on chapter 3, force, and today in today's class we will try to focus on other topics of important topics of chapter 3, as this is a very important chapter. So we have to review in a very well manner, so that all the contents, all the topics can get clear to us. So let's start our class, boys. In our last class, we were just discussing about force, different kinds of forces, um, what are the types of force, and in our today's class we will try to discuss about Newton's laws of motion. At first we will just focus on this topic, Newton's laws of motion. As you know, this is a very important topic. There are three laws of motion given by scientist Newton. Three laws are so much important for your creative type question or for knowledge based questions. And these laws are such kind of laws you have to know all time if you just want to study with physics, study with science. So just try to remember the laws. First law, Newton's first law. From first law we just can get the idea or concept of force. What does the first law state? A stationary object will remain stationary, and an object in uniform motion will continue its uniform motion unless a force applied to it. That means if any forces are not applied, the object will remain at its present condition forever. Because without force there will be no movement or no motion. This is the first law of Newton. Second law of motion. What is the second law of motion? From second law of motion we get the equation or idea of calculation of force. What is the second law? States the rate of change of momentum of a body is proportional to the applied force acting on it, and the change of momentum takes place in the direction in which the force acts. That means there is a relation between force and momentum. Second law makes the relation between force and momentum. The rate of change of momentum with respect to time is proportional to the applied force, and in the direction of force the change of momentum takes place. This is simply the second law, and from this law we just get the familiar equation, or the common equation F equals ma. Third law. What is the third law? When an object applies a force on another object, then the second object will also implies a force of equal magnitude on the first object, but in the opposite direction. First object applies force, and in contrary of that, second object also applies same amount of force in magnitude, but the direction will be opposite. These are the three laws of motion given by scientist Sir Isaac Newton. So we have known about the laws, three laws of motion. Then momentum, we have got the idea of momentum in from the second law. What is momentum? Momentum is just the product of mass and velocity. It is denoted by P. That means P equals mv. This is a vector quantity. Why is this vector quantity? As we know from vector quantity, the product of a scalar quantity and a vector quantity will be a vector quantity. Here mass m is a scalar quantity and velocity v is a vector quantity, and their product will be a vector quantity. So momentum is a vector quantity between two moving bodies. You have to remember one point here, that is, between two moving bodies with the same mass, the one with more velocity will have more momentum. If the bodies have same amount of mass, the body with more velocity will have more momentum. So we have known about momentum. This is a quantity and this is a vector quantity, and its unit is kg meter per second. From our equation P equals mv, we can calculate the unit is kg meter per second, and dimension is mlt inverse 1. Always remember one thing: whenever you will write the dimension, you must use the third bracket here. Another important point is the direction of momentum. As this is a vector quantity, it must have an direction. The direction of momentum of a moving body is the direction of its velocity. As between two quantity of mass and velocity, the velocity is the vector quantity, and its direction will be the direction of momentum. Okay. So we have known about momentum, the quantity momentum. Then conservation of momentum and energy. Another very important topic of this chapter is conservation of momentum and energy. What does we mean by conservation of momentum and energy? If two objects of different mass, for example m1 and m2, and different velocities, if their initial velocities are u1 and u2, collide together, and hence their velocities are changed because their masses are different, their initial velocities are different. So whenever there will be a collision, hence if their velocities are changed and final velocities becomes v1 and v2, then after the collision the combined momentum will not change. After the collision, combined momentum will not change. That means before collision, what was the combined momentum? That will remain same after collision. So this law is the conservation of momentum. Combined momentum of two objects before collision is m1 u1 plus m2 u2, and combined momentum after collision is m1 v1 plus m2 v2. So according to the law of conservation of momentum, we can write m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. These equations are already familiar to you, and this is a very important question for important type equation for your CQ questions, because conservation of momentum and conservation of energy, from this topic every year, almost in every year, both question comes from this topic, from this chapter. Specific from this specific chapter, this specific topic is very important for CQ type question. We have known about conservation of momentum and conservation of energy. From the law of conservation of energy, we can write the kinetic energy, the combined kinetic energy of the object before collision will be equal after collision. Okay, and then the equation can be in this form: half m1 u1 square plus half m2 u2 square equals half m1 v1 square plus half m2 v2 square. This is the law of conservation of energy. Whether in a collision momentum is conserved or energy is conserved, we can calculate this term by using these two equations. Then let's try to know about gravitational force and acceleration due to gravity. You have known about gravitational force in this chapter. There are four fundamental forces. The gravitational force is one of them, and this is the weakest force of all fundamental forces. What is gravitational force? Can you recall it? The force, attractive force between two objects is called gravitational force. And acceleration due to gravity, what is the definition of acceleration due to gravity, or acceleration due to gravity? This can also be said as gravitational acceleration. We will try to calculate the value of this acceleration. So from the law of gravitation, this also was given by scientist Newton. If two masses are m1 and m2 with a distance r, then the gravitational force acting between the object is F is proportional to m1 m2 divided by r squared. That means the gravitational force is directly proportional to the product of the mass of the objects, and is inversely proportional to the square value of distance. So this is the law of gravitation. F is proportional to m1 m2 divided by r square. From here, by removing the proportionate sign, we can write F equals G m1 m2 divided by r square. Here capital G is called gravitational constant. This is a constant term, and it has a specific value, that is 6.67 into 10 inverse 11 Newton meter square kg inverse 2. You have to memorize this value for MCQ type question, for mathematical terms. Whenever maths comes from this equation, most of the times the value of G are not given. Value of G is not given, so you have to memorize this value for any kind of question. The G is the gravitational constant between two masses. In our law of gravitation, we have uses two masses m1 and m2. Instead of using these two masses, if one is earth with mass m, that means capital M, and other is of mass m, small m, then the gravitational force will be G, F equals G into m small m capital M divided by r square, where capital R is the radius of the earth. The radius of the earth is a fixed value. You have to remember this also. The value is 6.37 into 10 inverse 6 meter. You can write it as meter, or you can convert it into kilometer. And the mass of the earth, that is also a fixed value, 6 into 10 to the power 24 kg. This is just quite better if you try to remember this term. That means radius of the earth and the mass of the earth. So we have seen the equation F equals G small m capital M divided by r square. So what is the use of this equation? From our second law of motion, we know the a familiar equation F equals ma. Here a few moments ago we have determined the value of F equals G small m capital M divided by r square. So we can write it here, and as this is a gravitational force, we can write small g, where small g depicts the gravitational acceleration instead of using acceleration A. Here we are using gravitational acceleration instead of just simple acceleration. So after calculating, we can write small g equals gm divided by r square. A very, very important equation. You have to remember this equation always. So if you just put the values of capital G, that means gravitational constant, value of mass, value of radius in this equation, you will just get that G equals, that means gravitational acceleration G equals will be 9.8 ms inverse 2. Remember one thing, that this is not a constant value. In the equation of G, we have seen G equals gm by r square. R is the radius of the earth. So by the change of the radius of the earth, the value of G will be changed. Though the value of capital G and value of mass is fixed, but r, the radius of the earth, r is different at different places. So that's why the value of G, small g, or that means the value of gravitational acceleration is not same everywhere. So we have seen the acceleration that occurs between Earth and any other object due to gravitational force is called gravitational acceleration. If we want to define gravitational acceleration, or want to know the definition of it, that will be the definition: the acceleration that occurs between Earth and any other object due to gravitational force is called gravitational acceleration, or acceleration due to gravity. This and the unit of this term is same as the normal acceleration, that means ms inverse to meter per second square. Another important term here is, if gravitational acceleration at r height from Earth's surface, that means if we just want to move at a higher distance from the Earth's surface, at a height from Earth's surface, then what will be the gravitational acceleration? Here we have considered the height is r, so our new gravitational acceleration G prime will be gm divided by capital R plus small r whole square. If we just approach from the Earth's surface and go to the higher height, then this will be the equation of gravitational acceleration. At the same way, just like the same way, if we move at a depth of from Earth's surface, so there will be a change in gravitational acceleration too. So you have to remember this equation also for mathematical type question, because some maths related to the variation of gravitational acceleration comes to your board exam. So using this equation or all the equations, you must have to practice your creative type question. So boys, in our today's class, just we have focused on Newton's laws of motion. Today's classes topics are very much important topics. First one was Newton's laws of motion. 3 laws are there. You have to remember, you have to memorize all the 3 laws. First law, the stationary object will remain stationary, and an object in uniform motion will continue its uniform motion unless we just apply a force to it. Second law, the rate of change of momentum of a body is proportional to the applied force acting on it, and the change of momentum takes place in the direction in which the force acts. Third law, when an object applies a force on another object, second object will imply same amount of force but in opposite direction. From these 3 laws, we have known about momentum. Momentum is P equals mv. This is a vector quantity. We have known its unit, its dimension. Then the conservation of momentum and energy to so much important equations are here. From conservation of momentum, m1 u1 plus m2 u2 equals m1 v1 plus m2 v2, and from conservation of energy, half m1 u1 square plus half m2 u2 square equals half m1 v1 square plus half m2 v2 square. Sorry boys, here the equation will be m2 v2 square. Just try to make a correction here. And Then we have known about gravitational force and the relation of gravitational force with acceleration due to gravity. Newton acceleration due to gravity or gravitational acceleration, its value is 9.8 ms inverse 2, and this is also a vector quantity. And why the value of gravitational acceleration changes at different places, we have also known about this. So guys, hope all of you have understood today's topics, today's lecture, and try to take some notes from lectures, that especially the equation type equations. You must just use a regular notebook for your classwork, and whenever I will give some homework, you will just try to solve that, and that will be counted for your SPM marks. So guys, that's all for today. Thank you again, and take care.